The next thing to refer to is the consistency, or what's referred to as consistency. But really, I don't think it's a great choice of word. This is about how confident you are in your results, in being able to get a similar trend if you were to do the experiment again. And the two things that contribute to this are, firstly, the repeatability of your results, which means how close your results are, how close together your results are. So with your repeats are closely centered around the mean, which corresponds then to error bars being small. If they're all closely centered around the mean, then that would imply that your error bars are likely to be small. Well, that would make you more confident in your results, because it implies then that if you were to do it again, you would continue to get a value that is close to the mean you obtained, and therefore we're unlikely to see a different trend if you were to do it again. Compare that to if they aren't closely centered around the mean, and the understanding of this is important. If they're not closely centered around the mean, then it's possible, or rather, it's quite feasible that if you were to repeat it again, it's really difficult to gauge exactly where that result would lie. Would it be close to your mean? Well, a lot of your other readings weren't. So why would you expect this one to be close to the mean? That is, you're just not confident. Now, those really relate to treating one row at a time, or one set of repeats at a time. The second part that's significant here is whether your error bars overlap. So in order to just emphasize the importance of this, I'm going to show you, look at this graph in detail. Right, so if we looked at this set of results here, whereby obviously you've got the independent variable on the x-axis and the dependent on the y, it's just taken from another possible experiment. This is relating really to an enzyme control reaction, and you can see that as temperature increases, the time decreases, suggesting that this value here, or this value down here, the 40 degrees C, would be, according to our results, the optimum temperature. Again, I say according to these results because we don't know, the optimum could be there or the optimum could be there. We don't know because we haven't tested those, but according to the results, that's the optimum. Now let's look at the error bars in detail, and here's the problem. It is perfectly feasible, because we had results to this effect, that value there could be as high as the limit of the error bar in that position, or as low as the limit of the error bar in that position. If we go to this one, we get the same idea. That value that we've plotted there, perfectly feasible to be as high as that or as low as that, because we actually had values that went as high as that and as low as that. So what does that mean? Well, actually, if I manipulated the position of these plots, but kept them within the error bars themselves, I could actually change the outcome. So I'm going to draw on here and try and show you this. So let's have a look. If I can now join this line up here, and rather than join it to that plot, I'm just going to join it to the bottom. Forgive the drawing, I know it's not great. And now I'm going to join that with the top of the error bar there. And if I kept the other ones the same, then now compare the two lines. Well, look what's happened. Because I have overlapping error bars between that one and that one, notice the overlapping, look how that line there, if I trace it along, is within this error bar. By simply manoeuvring these points at will, you know, have the freedom to do so as long as they're within the error bars, I've actually now, according to my, look at that red line, where's the optimum now? Well, the optimum now is at 25 degrees. So overlapping error bars is all about confidence in your results. And because I can quite feasibly manipulate this plot to be somewhere else within the error bar, and indeed this plot, well, and indeed any plot, it's where they overlap that I can actually have a significant impact on the overall trend that I've stated. The optimum now was there, but just simply by moving the mean values, these plots, but still keeping it within the error bar range, I can actually change the optimum. And therefore, it's feasible that this is actually the optimum, because I had a set of results which could imply that. The means do indeed imply that this was the optimum, but the overlapping error bars reduce our confidence to that effect. Now, if I take that line off, if you then do the same, and if we took it from this position here to this position, you see how they don't overlap? So let's go the opposite. What if we said the error bars didn't overlap? Well, if I try and manipulate it in the same way, so I'll go from that plot there, I'm going to go to the top of the error bar there and the bottom of the error bar there, and then carry it on. Well, that doesn't make a difference. You see, you notice even by doing that, this value here, even if I put it there, is still lower than that value there. So even by trying to even get them close, if I was trying to try and manipulate the data, I still have this value here being lower than this value here. As a consequence, I'm confident that those two are different, 1, and 2, that this value here is lower than this value here. Because even within the range of the error bars, if I allow myself to go to the extremes of those error bars and manipulate it at will, this value will still be lower than this value. That doesn't hold true, for reasons I just showed you, between these two. Because there's overlap in error bars, whilst we're saying this value is lower than this value, it's possible, by moving that value down here and moving that value up there, that this value actually could quite feasibly be lower than that, and now my trend has changed. Okay, so overlapping error bars imply that overlapping error bars indicate a drop in confidence in our trend. When they're not overlapping, then we are increased in confidence in our trend. So let's have a look at an example of what we might say. So there's two possible examples here. I've said I'm confident in my trend as the experiment was repeated at each temperature and results are that it is closely centered around the mean, which generally means that error bars are small. So usually those two things go hand in hand. The error bars do not overlap, so increasing confidence in my trend. Now we could reverse those and say they're not closely centered around the mean and they do overlap, but you could actually have a combination of the two. So I've said that here. I'm not confident in my trend as the experiment was repeated at each temperature and results are not closely centered around the mean. Error bars are large. That said, error bars also do not overlap, so making me somewhat, probably don't need also in there, sorry. Error bars do not overlap, so making me somewhat more confident in my trend. So one aspect can reduce your confidence, another aspect can increase your confidence. It's not an either or situation. It's not that you are either confident or not confident. You are somewhere between the two, and you just make reference to each thing indicating the level of confidence or how it affects your confidence. I'll just add one more thing. It is quite tricky sometimes to make a judgment as to whether your results are closely centered around the mean or not. Error bars overlapping is plain to see. There's no subjective nature there, but whether your error bars are big or small, there is a subjective nature to that. And I guess the more you do, the more you can be qualified, I suppose, to form a judgment. But, you know, we could differ over it and would both be right.